So we're looking at 9.2 homework today, starting with number 25. So here we have a regular square pyramid, means we have a square on the bottom, and then it's coming up, its intersection for the altitude coming down like this is a right angle. All of its lateral edges are the same. So suppose the altitude has a measure equal to that of the edges of the base. So basically what it's telling me is the height here of this pyramid is the same as the base edge, and I'm told that's X. I don't know what that is, but I am told the volume of this thing is 72. So I want to find the total area of the pyramid. All right, so here I'm told some stuff about the height as it relates to the base edges. So I'm going to say my side length here equals X. And I'm going to say my altitude equals X as well. I'm going to draw it off to the side, so I don't want to interfere with the picture too much, but oops, that's not a very good X. There we go. So height of this thing equals X. So if I wanted to talk about the volume of a pyramid, that's the first thing I want to talk about because I'm given if the volume of the pyramid is 72 inches cubed. Okay, so volume for a pyramid, last time I checked, was 1/3 my base times my height. Maybe we use capital B here, I don't remember. So as I look at this thing, I'm saying, okay, well, my base is going to equal X times X because it's a square, that's X squared. And for my height, I know that is X as well. So my volume here really just turns into 1/3 X cubed, and I'm told that equals 72. So my next step here is I'm going to multiply both sides by 3. So 72 times 3 gives me what, 216? So X to the third equals 216. Again, I don't expect you guys to have these like cube roots memorized. So I would just take the cube root of both sides here, and I see this one is 6. So here now I have X equals 6. Now the question it's asking is find the total area of the pyramid. So now that I know the X length, I can go back and figure out what my slant height is, and I'm going to need that to figure out the total area. I guess you could use lateral edge, but that's the easiest way is to use slant height. So now I'm going to just draw specifically the bottom. This is my base. So now I'm going to label this thing. I'm going to label it with the information that I know, which is that it is 6 by 6. I'm going to put the center of my base in like this, and I'm going to draw a line segment down like this, but I'm going to do it in, oh, I just used green. Let's use blue. Okay, this right here is A, my apothem. My apothem for this regular quadrilateral, aka a square, is going to be 3, right? This is half the side length. So if this was a hexagon, you should be able to figure it out. If it were an equilateral triangle, or excuse me, a regular hexagon, and if it was an equilateral triangle, we should also be able to figure this out. So now I know this thing is 3. Now I want to think about, okay, well, if my apothem is squared and I say plus my height squared, it's going to, let's choose another color, equal my slant height squared. So this relationship is something we need to be able to use, and I'm going to try and represent this in our picture without making it look too bad. So this is my apothem coming out like this. Here is my, there's no way we'll be able to see this. Yeah, that's poor color choice there, Mr. J. Using orange to represent the height here. And then this purple right here, it's not purple, it's indigo. Let's get our colors right. So here we got that slant height right here. If I were to just draw one of these triangles, we can figure it out other ways too. I'm not going to pursue this route, but I'm going to talk about it briefly. If this is 6 and this is 6, then this distance across diagonally is going to be 6 root 2. So half of that is just going to be 3 root 2. So if I want to use my radius of 3 root 2, find my lateral edge, and then use that along with my base edge to figure out slant height or just to figure out the area for this lateral face, you can go that route as well. Again, just, I briefly said it there. If you want to rewind the YouTube video and check that out, you can. It's more work that way. That's why I'm not going to do it. I'm lazy. I don't want to do more work unless I have to. So we're going to add our height here squared. It's going to equal our slant height squared. So at this point, I'm just going to kind of jump to it. So this is 3 squared is 9. My 6 squared gives me 36. So 9 plus my 36 gives me 45. I'm going to take the square root of 45. The 3 is going to factor out. So I'm going to get 3 root 5 equal to my slant height. So again, if you didn't follow everything there, this is just, I don't know. I go back and forth whether I should write the whole thing out, but factor this into 9 and 5. And then from here, this 3 squared can come out as a 3 on the outside. So here's where we get our 3 root 5 from. From here, now I want to jump back into what it means to have my lateral area for a pyramid, right? Lateral area for a pyramid is going to be 1/2 slant height times perimeter. So as I look at this thing, I think, okay, well, my perimeter is just going to be 6 times 4. That part's pretty easy. So got 4 times 6 equals 24. And then from here, I know my slant height was 3 root 5. So I'm just plugging all the pieces in. So now I'm going to say my lateral area is going to equal 1/2 times 3 root 5 times 24. 24 times 1/2 gives me 12, times 3 gives me 36, and then root 5. So that's my lateral surface area. The question is asking me for my total surface area. Total surface area for a pyramid is going to include one base plus the lateral surface area. Now I just need to figure out my base. Well, the base is pretty straightforward. This is a square. I've got sides of 6, so my base is going to be 36. So now as I look at this thing, my total is going to be equal to 36 plus 36 root 5. And I am done. Any questions here? Perfect. All right, we'll go on to 27 here. And if you want to find an approximation for that, I'm quite confident you could. I think it comes out like approximately 116.5 or whatever. But I don't really care about approximations. Exact answers are better. All right, let's look at 27 here. So in this one, very, very similar to the last problem we did, dealing with another square pyramid, but really this one is different in that we're provided a little bit of a twist in the information. So the last one, it told us, a relationship between the height and the base. And so now here we're given a church steeple in the shape of a regular square pyramid and needs to be reshingled. All right, cool. So part of this corresponds to the lateral area. So the thing that we're looking at is just the outside. We're not looking at the base. So just trying to shingle this thing, we need all the lateral area. To do so, if each lateral edge measures 17, so let's jot that bit of information down. I'm also going to color one right here, and I'm going to color one right here, just so we can see what those lateral edges are. And I'm going to say that lateral edge, equals 17. Each base edge, so I'm going to say side length here, equals 16. And I'm going to highlight that at the bottom here. So now I want to look at the triangle that I just created. This is probably the easiest way to do this problem. Again, there's multiple ways we could do it. This I think is the easiest. So here's my orange one right there. So we know that we've got 16 and we have 17. If I have this set up, I can always take my altitude and drop it down. So again, the reason being is because we have an isosceles triangle, I know that this is going to intersect, and it's going to intersect at the midpoint at a 90. So this is being bisected. So this new segment here is going to be labeled in blue, 8 and 8. So I'm going to just try and draw a little blue here. So this is 8, this is 17, and this is at a right angle. Is there some way that we can figure out what this slant height is going to be? Yeah, that's the thing that I want. So here I'm going to set this up. I don't know what this thing is. Let's call it x squared plus 8 squared equals my 17 squared here. So now I'm going to do some math to this thing. So 17 squared is 289. I'm going to subtract off my 8 squared, which is 64. So I get my x squared is, 225. From here, I'm going to take my square root. take my square root. Now when I look at 225, I see it's a multiple of 25. So I do this and I say, okay, well, it's a multiple of 25, so I can do 5, and then it's a multiple of 9, so I can do 3. So if you want to see this as 15 right out of the gate, that's great. But again, if you don't identify those things, I don't know. I kind of expect people to know up to 10 as like squares, but like once you get like past 10, it's kind of like a 50-50 shot whether you know up to 15. And I really wouldn't expect you to know anything past 15, except for like maybe 20 being 400. But yeah, so I get my x value here is 15, and then from there I'm saying, okay, well, I want to find the lateral surface area. I know my lateral surface area, just like the problem we did before, is going to be 1/2 slant height times my perimeter. To figure out perimeter here, again, I have all 16 for these base edges. So I'm just going to do 16 times 4, and my perimeter is 64. So now I'm going to multiply this stuff out. 1/2 15 times 64, and we get 480. So how many square feet? 480. Any questions here? Perfect. Let's look at our last one here. So here we have a street department store building. It's used to store the rock, gravel, and salt used by city roadways, built in a shape of a regular hexagonal pyramid. That's the thing that I care about. I mean, not that I don't care about the city's salt and sand needs, but really. Altitude of the pyramid is the same length as any of the base sides. Volume of the interior is this thing. Well, that wasn't the best underline. Find the length of the altitude. All right, cool. So the thing that I care about is this thing's a regular hexagonal pyramid. Okie doke. So let's draw a picture. I'm just going to freehand a regular hexagonal pyramid real quick. Oh, man, did it again, Mr. G. Classic. So I don't know what these things are, but I do want to draw. I guess I'm not going to even pretend to draw the base of this thing. It's not going to come out good. But it's a pyramid, right? So since it's a pyramid, I want to know its altitude. So altitude is going to be important to me, along with knowing what the base is. So here, if it's a regular hexagonal pyramid, all these sides are going to be the same. So keep that in mind. We're told the volume for this thing. Volume is 1/3 my base times my height. So in determining what the area of my base is going to be, I can use a variable. Let's say we use x, right? If each of these is going to be x, I know that it is a regular hexagonal base. So I should be able to do some extra, look at that line, that is quality. And do some extra stuff based on the fact that this central angle used to be 60 degrees. I bisect it with my 90 here. This is now my 30. This is now my 60. If you want to think about it as the interior angle used to be 120 and you bisected it, whatever floats your boat. So now I get this 30, 60, 90 triangle. This thing right here used to be x. I just split it in half. So now this is x root 2. And now I'm going to talk about what the value here, or excuse me, this is 1/2 x. So in terms of what the value is going to be, this is going to be root 3 times that. So this is going to be 1/2 x times root 3. So I'm just going to draw out that triangle in case people didn't follow just based off the words coming out of my mouth. So here, this is my 30. This is my 90. This is my 60. This used to be x, but I cut it in half. So this is now 1/2 x. The 1/2 x is my x value, right? Across from my 30 is my x, so I'm just going to call that my a. Across from my 90 should be 2a, and then right here should be a root 3. So again, 30, 60, 90 triangles, good stuff. This is the thing that I care about. I really want to know the apothem of this, but if you wanted to just do this as a equilateral triangle and multiply it by 6, you can go that route as well. So this is just personally how I would do it. I would do 1/2 the apothem times perimeter. But if you just want to figure out the area for one of these triangles and then multiply that thing by 6, that's fine too. So again, multiple ways to arrive at the same answer. So looking at this thing here, this is going to be 1/2 x times root 3. So the thing that I care about, I'm going to do with a blue star, and that a root 3 is going to be root 3 over 2 times x. So this is my apothem. So the reason I care about my apothem is that this is going to be used in my formula for the base. My base is going to be 1/2 my apothem times my perimeter. Perimeter for this thing is just going to be x times 6. So this is going to be 6x. So now I'm just going to plug all this stuff in. My base turns into 1/2, oops, times, here's my root 3 over 2 times x times 6x. So here, the 6 and the 1/2 are going to cancel off, or you could turn this into a fourth and then cancel it off after. It really doesn't matter. So this is going to now turn into 3 root 3 over 2. So again, 1/2, and then 1/2 here is 1/4. 6 over 4 is going to be 3 over 2. So there's my 3 over 2. The root 3 is just coming along for the root 3 ride. My values here now, x and x is going to give me x squared. And you can write it in the numerator too. It doesn't really matter. I typically will write it off to the side, but it's whatever. So this is now my base. If this is my base, then I want to take this and plug it back in with my height. Well, what's the height? We said the height of this thing was just going to equal the base edge. So this is just going to equal x, right? We said it was x over here. So now we're saying it's x right here as well. So now when I'm plugging all this stuff in, I've got 1/3 times my base, which is root 3. Oh no. Try it again. 3 root 3 over 2 x squared. Here I got times another x. So now this is going to give me x to the third. And now here this 1/3 and the 3 are going to cancel off. So it's really just going to equal root 3 over 2 x to the third. And we know this volume was given us to be 11,972. Now's the point where I can start doing my approximation. So here what I'm going to do next is I'm going to divide both sides by this root 3 over 2. If you want to think about it as multiplying by 2 and dividing by root 3, it's literally the same thing. So do that step first. So divide by my root 3 over 2. So I don't know, let's see, 11,972 divided by square root 3 over 2. Make sure to get your parentheses right. And we get x to the third is approximately, let's see, 13,824.07. And now again, I don't really want to do anything on my calculator. I want to keep it with this other junk because it'll keep on, continuing with the decimal. I just want to raise that to the 1/3 or take the cube root of that. It's the same thing. And I get my x value is pretty darn close to 24. So now I am good to go. So find the length of the altitude for each side to the nearest foot. Here we're just going to round. Rounds pretty clean to 24 here. Any questions on this one? Perfect. I think that's all we had. Yeah.